Finally, what I want to do is to move on to how do pollutants affect stone and monumental heritage. And we've talked a little bit about this. We hinted that erosion of stone might be affected if there are acids in the surface, in this water that gets onto the surface of stone buildings. And traditionally, the big driver of this was the sulfur dioxide from coal smoke. And what happens here is that sulfur dioxide deposits on wet surfaces. And if we think of a stone being something like limestone or calcium carbonate, the sulfur dioxide deposits onto the surface. If there's water there, that sulfur dioxide can be converted to sulfuric acid, and effectively the sulfuric acid dissolves the limestone. It converts the limestone from a carbonate into a sulfate. The sulfate is gypsum. And gypsum has a larger molecular volume than limestone. So what happens is when you do this conversion, the stone essentially expands. So the surface, this weathered surface that's being sulfated, expands. And this expansion disrupts the surface. In fact, it often exfoliates outwards because the sheet of stone on the surface is looking for space, so it breaks outwards from the surface. Sulfur dioxide concentrations are now low in most cities, but they're still sufficient to cause some sulfation of the surface. This damage, where we have a conversion from limestone to gypsum, not only changes the volume, it also changes the solubility. Gypsum is much more soluble than calcium carbonate, so the limestone is less soluble than the gypsum. And what this means is that this gypsum that's been produced in perhaps a polluted environment is going to dissolve more readily. So in a sense, we've got two processes taking place that have led to an expansion, mechanical stress. So in a way, the building is almost exploding outwards, but it's also dissolving more rapidly once these changes have taken place. And the mechanism is really fairly simple. It's just this formation of acids that essentially change the composition from a carbonate to a sulfate. These layers of sulfate are often colored by soot because generally coal-burning cities not only produce sulfur dioxide, they also produce lots of dark black smoke. And what we have is these layers are not white. Gypsum is a white mineral, but they're black because they have coal smoke particles, carbon particles deposited in them. Of course, we don't burn coal anymore, but we have cities full of diesel smoke, and naturally the diesel smoke is very black. So there's still plenty of blackness on the surface of modern buildings, even if we don't have coal smoke. We can also have the interaction of other pollutant gases, the nitrogen oxides, ozone in cities, and these interact with the sulfur dioxide, and they can cause the formation of sulfuric acid to be more rapid. And this more rapid production of sulfuric acid can mean faster rates of corrosion. So cities are pretty dangerous places for buildings if the air is polluted. Fortunately, in most cities, sulfur dioxide has been in decline. There are also a few pollutants actually produced almost biologically on the stone, and these tend to be things such as oxalic acid. And the oxalic acid on the surface of the stone tends to produce a range of minerals, the calcium oxalates, and these calcium oxalates can be found as layers on stone in cities, even where they're not corroding due to sulfur dioxide from pollution. Sometimes these aren't really from biology at all. They're a degradation of earlier stone treatments that use particular organic materials. So in a contemporary sense, we're rather lucky. What's happened is that we've got less sulfur dioxide in cities now. So sulfur dioxide was traditionally a phytotoxin. So sulfur dioxide as a phytotoxin killed lichen. So we didn't get much lichen growth on cities 100 years ago that burnt coal. However, we've got rid of the sulfur dioxide from cities now. And so what that's meant that sulfur dioxide is not so important, but modern pollutants from automobiles and things like that, like sort of industry, tends to produce more and more nitrogen dioxides. The nitrogen dioxides don't end up as sulfuric acid on the surface of a building, they end up as nitrates on the surface of a building. Nitrates are effectively a fertilizer. So what we've done is we've removed sulfur dioxide, which is a toxin to lichen. We've added a kind of fertilizer, the nitrates, from the modern pollutants. And so what we've ended up with, something that allows richer biological growth on the surface of a building. So that's been a big change. So we, at the moment, might expect a bigger range of lichen on the surface of buildings.